Hey you guys, this is Mr. Millings, and in part 2 of a 6-part series on challenging mole conversion problems involving densities and shapes, we are going to learn how to apply these concepts to cylinders. So let's jump right in and take a look at an example. In this very first example here, it says a platinum cylinder has a height of 3.80 centimeters and a radius of 75.1 centimeters. We need to calculate the number of atoms that make up the cylinder, and we need to round our answer to 3 significant figures. So if we read this question or this word problem, it tells us that we have a cylinder, and this cylinder is made out of platinum, or PT. What we also know about this cylinder is that the radius of this cylinder here is equal to 75.1 centimeters. And we also know that the height of this cylinder is equal to 3.80 centimeters. So what I recommend you do is when you come across problems like this involving density and mole conversion and shapes, is draw yourself a little picture and label what's happening. So we have a platinum cylinder here. We know its radius is 75.1 centimeters, and we know its height is 3.80 centimeters. And what we have to do is we have to figure out the number of atoms that make up this platinum cylinder. So how are we going to do that? Well, if we take a look, we know the radius and the height of this cylinder. And so in our very first step, what we can do is we can find the volume of this cylinder using the volume of a cylinder formula. And you can go ahead and Google this. I'm going to go ahead and give it to you, but you should typically learn the volume of a cylinder in an Algebra 1 course or your geometry course. The volume of a cylinder is going to be equal to pi times r squared times the height of the cylinder. So in step 1, what we're going to do is we're going to find the volume of this cylinder. And so after we get done finding the volume, what can we do next? Remember, we want to figure out the number of atoms that make up this cylinder. And so if we can somehow figure out the mass of this cylinder, we can then run it through this process here and figure out the number of atoms. But how can we figure out the mass if all we know so far is the volume? Well, you guessed it. In step 2, what we can do is we can use the density formula. Density is equal to mass divided by volume. And so if we figure out the volume in step 1, we can then plug that into the density formula in step 2. We can then refer to a density table to figure out the density of platinum, and we can solve for the mass. And so once we figure out the mass in grams, what we can do in step 3 is we can now figure out how many atoms there are in this platinum cylinder here by running it through the mole conversion process. So in step 3, we're going to do some mole conversion to figure out the number of atoms that make up this platinum cylinder. So let's go ahead and start with step 1. In step 1 here, we are going to use the volume of a cylinder formula to figure out the volume of this platinum cylinder. So the volume is going to equal pi, which you know is 3.14, times the radius. What's the radius here? It's 75.1 centimeters. We're going to square this, and then we're going to multiply it by the height, 3.80. And so when we put this in our calculator, when we take 3.14, multiply it by 75.1 centimeters and square that, and multiply it by 3.80, we'll end up with 6.73 times 10 to the fourth Centimeters squared times centimeters is cubic centimeters, which is a unit of measurement for volume. And so because when we put this in our calculator, it was so big, or the value was a large number, we went ahead and converted this into scientific notation. But this is essentially the same thing as approximately 67,300 cubic centimeters. So that is the volume of this sphere right here. So now that we know the volume of our sphere, what we can now do is we can now, in step 2, we can now use the density formula, density equals mass divided by volume, to figure out the mass of this platinum cylinder here. So if we take a look here, we know the volume, we just figured that out. We can look on a density table, some sort of reference material. You can even Google this and find the density of platinum in grams per cubic centimeter. And then we can solve for M, or the mass. And so, if we take a look at a density table, we can see that the density of platinum is 21.090 grams per cubic centimeter. So we know the density of platinum is this. We know the volume of this cylinder is this right here. How do we find the mass? Well, if we know that density equals mass divided by volume, we want to get mass all by itself on one side of this equal sign. So we'll multiply both sides by volume. Volume is going to cancel. And so the mass of this platinum cylinder is going to be equal to the volume times its density. So what is the volume of this platinum cylinder here? We just figured that out. It's 6.73 times 10 to the 4th cubic centimeters. And we're going to multiply this by the density, which we just figured out is right here, 21.090 grams per cubic centimeter. And so when we put this in our calculator, we end up with a mass of 1.42 times 10 to the 6th. Let's see what cancels out. Centimeters cubed and centimeters cubed are going to cancel out, leaving us with grams. So here is our mass. This is going to be our mass of this object in grams. So now that we know the mass of the object in grams, what we can now do is run it through the mole conversion process to figure out the number of atoms. So let's go ahead and do that right here. In step 3, we know the mass in grams of this platinum cylinder here. It's 1.42 times 10 to the 6th grams. And what we want to do, we also know that this is platinum. So what we want to do is we want to figure out the number of atoms this is. So we want to cancel out grams of platinum first and convert it to moles. Like it says right here, go from grams to moles and then go from moles to atoms. And after we're done with that, we want to cancel out moles of platinum. So we'll put that at the bottom of our fraction or equivalence statement right here. And we're going to convert this to atoms of platinum. So what's going to go right here? Well, this is where we look on our periodic table and find the molar mass of platinum. And if you take a look at the periodic table that just popped up, you'll see that the molar mass of platinum is 195.08. 195.08. This means that for every 1 mole of platinum, it's going to have a mass of 195.08 grams. And so what about right here? Well, we know that 1 mole of something is going to be equal to Avogadro's number, or 6.02 times 10 to the 23rd. So if we take a look now, grams of platinum in the numerator and denominator can cancel. Moles of platinum in the numerator and denominator can cancel, leaving us with atoms of platinum. And we'll put the answer down here. So, atoms of platinum is what we were trying to find. So now we just put this in our calculator. We'll take 1.42 times 10 to the 6th. We'll divide this by 195.08 since the molar mass here is in the denominator. We'll take this divided by this. And since Avogadro's number is in the numerator, we can multiply by 6.02 times 10 to the 23rd. And we're going to end up with a final answer of 4.38 times 10 to the 27th atoms of platinum. So to go back to our original question, if we have a platinum cylinder that has a height of 3.80 centimeters and a radius of 75.1 centimeters, how many platinum atoms make up this cylinder here? 4.38 times 10 to the 27th. If you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that's going to subscribe you to my channel, and feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.